Now, what happens when you get really close to a number but never touch that particular number? The answer lies in the fascinating world of limits in calculus, and that's the reason for this video. Now, welcome to Post Scholars channel. If you are preparing for NECO exam, WAEC exam, JAMB exam, or any other college exam, then be rest assured that this video is for you. You see, the topic before us is limiting value of a function. Limiting value of a function. By now, you should know what a function is, right? Because I explained it in the first video of this playlist, right? A function is a rule that takes in an input and gives out an output, right? For example, if you have y is equal to 2x, right? This is an example of a what function, because as x takes a value, it produces what? Y. For example, if x is 2, right? Y, if x is 2, comma, right? Y is going to be what? 4. If x is 3, y is going to be what? 6. Do you understand? So as you take in an input, you get a corresponding what? Output. That's what function is all about. Now we have two examples in limit that we are going to solve together, right? The first example says find the limit as x tends to 0 of this function, right? This is a kind of polynomial function, right? Because the highest power here is what? Is 3. So how do we solve this? You can plug in 0 into the function directly, or you can solve it independently for each term. What does that mean? That means I can start by saying this limit now is equal to, right, limit as x tends to 0 for 7, then minus the next one is what? Limit as x tends to 0 2x, right? Then plus limit as x tends to 0 again of the function 5x squared, then minus limit as x tends to 0 for the function 4x cubed, right? We didn't do anything wrong. What we did was to sum their respective limits. Do you understand? We expanded it, then we continue solving. Now this is a constant, right? This constant is just 7. As x tends to 7, there's nothing there. So the limit of a constant is still that constant. So the limit as x tends to 7 for this constant is still 7, right? Then minus. Now next, this one says limit of 2x as x tends to 0. So when you plug in 0 here, 2 times 0 gives 0. So the value of this function 2x is 0. So minus 0 plus, next, limit as x tends to what? 0 again. So when you plug in 0 here, 0 times 0 is 0. Then that 0 multiplied by this 5 gives 0 again. So that's plus 0. Then minus, next, limit of this function 4x raised to power 3 as x tends to 0. That means as x gets closer and closer to 0. So when you plug in 0 here, 0 times 0 times 0 gives 0. Then 0 times 4 also gives 0, right? Then when you do the sum of everything, 7 minus 0 plus 0 minus 0 gives 7. Good. So what this limit is simply saying is that as x keep getting closer and closer and closer to 0, right, the value of this function becomes what? 7. So we are done with question 1. Now question 2 is quite different, right? Because the function is looking like a fraction, right? It's looking like a fractional function. Good. Now the question says we should find the value of this function, right, as x gets closer and closer to 5, right? So there are different methods of doing it. You can simply plug in 5 into this function instantly, but I want us to follow it in order. So for the numerator, we have limits as x tends to 5 x squared, right? Then plus Next, limit, we are working with the numerator now, as x tends to 5 again, of the function 5x, then plus limit as x tends to 5 for the function 9 or constant 9, over, right, limit as x tends to 5 for the function 2x squared, minus limit as x tends to 5 for the function 3x, then plus limit as x tends to 5 for the constant 15. So there's no issue here. So now you plug in the value. When you plug 5 into this function, what do you have? You have 25, right? Plus, next, when you plug in 5 into this function, you have 5 times 5, which gives what again? 25, right? Then plus limit of a constant, right? Limits as s tends to 5 for a constant. You can see there's no x here, there's no variable here. It's still 9. So that's the rule for limits. So plus 9 over, next, limits as this function, as limit as x tends to 5 for this function, because becomes 5 times 5. Remember, this is square. 5 times 5 gives 25. Then 25 times 2 gives 50, right? So 50 minus, next, limit as s tends to 5 for the function 3x. What you need to do, just say 5 times 3. This gives 15. Then plus, this is a constant again. You can see there's no x attached to this constant. So the limit of any constant remains the constant, right? So the value of this limit is 15. What's the next thing we do? We add up, right? 25 plus 25 gives 50. Then 50 plus 9 gives 59. So we have 59 for the numerator over, you can see, minus 15 plus 15 gives 0, right? So what's left is just 50. So write 50. So this is the final answer, or you can reduce it by saying how many 50 can you find in 59? That's 1 remainder 9 over 50. So this is the final answer. Good. Now let's go back to the question. It simply means that for this function, right, as x keep getting closer and closer and closer to 5, right, the value of this function becomes what? 59 over what? 50, or word number 9 over what? 50. So we have come to the end of this video. Now in the next video, I will be solving a kind of function that has an indeterminate form. So I wish to see you there. God bless you and bye.